The first row of the table shows aggregated data on world imports. Here are the overall imports of the product. In this case, the products contained under the HS6 code 071090, mixtures of vegetables frozen. The numbers are not black, but purple. This means that it is aggregated data, which is a mixture of data that was provided by the countries directly, that is direct data, and data for non-reporting countries that was reconstructed based on the data supplied by reporting countries. It is called mirror data. Only the trade balance amount is in red because it represents a negative balance. A complete explanation of the different colors can be found at the bottom of every table in TradeMap. So, the first column of data under Trade Indicators identifies the total value of world imports for the selected product. In 2015, the total global imports of frozen vegetable mixtures amounted to almost $697 million. The next indicator in the table is the trade balance, which is calculated by subtracting imports from exports. In 2015, the value of global exports was less than the value of imports by about $37 million, hence the negative number. Dividing the 37 million by 697 million, you can easily calculate that this corresponds to 5.3% of the overall import value. This difference between imports and exports, which theoretically should not exist for the global market, is a byproduct of the manner in which trade data is collected and produced all over the world. One of the causes of the discrepancy is that imports are typically reported in CIF, cost, insurance and freight terms, while exports are typically reported in FOB, free on board terms. Thus, there is a difference in total imports and total exports due to insurance and freight charges. But there are other causes as well. Unless the difference is significant, that is, larger than 5% of imports or exports, it should be disregarded and considered to be within the acceptable error margin of all statistical data. In this case, the error is larger than we would like, so we need to bear this in mind in any conclusion we draw. Following, we find the two columns indicating the imported quantity and the quantity unit, which state that the imports of the HS6 code 071090, mixtures of vegetables frozen, in 2015 for the United States amounted to approximately 82,000 tons. Next, we find a column that states the country's unit values for the product. These numbers are useful to compare the different importing countries. For example, within the 25 largest importers of frozen vegetable mixtures, we find a difference of unit values, ranging from $2,048 per ton for Japan to $775 per ton for Australia. There could be many explanations for this. For example, differences in the packaging size. Normally, we also find the world averages for the unit value, which in this case is $1,167. Sometimes, however, unit values for some countries or for the world are not displayed. This is usually due to a lack of data availability, or to the quality or heterogeneity of the data. If you encounter this during your search, we recommend you view the data in yearly time series, instead of trade indicators, and see if the data you are looking for is calculated there. When we move on to the trends section of the table, we can see that between 2011 and 2015, the market has decreased at a 2% average annual rate in value and a 2% average annual rate in volume. If we now opt to view the table in terms of products, we can compare the growth of the product with world growth for all products. We can see that in the last 5 years, demand for frozen vegetable mixtures has decreased 2% in value terms. That is the same decreasing rate for the imports for all products. If we compare growth over the last year in import values for this product with world growth for all products, we see that the demand for all products has decreased by 13%, and the demand for mixtures of frozen vegetables decreased by 12%. As a supplier of vegetables, you may want to investigate this further, looking at each of the importing countries individually, and in particular, at their quarterly and monthly data to see where demand may be increasing or decreasing most. If your company is exposed to weakening markets, you may want to diversify your markets to those where demand is stronger. Now, switching back to the view by country, we can see that out of the top 10 markets by size, growth in import value from 2011 to 2015 contracted in half of them. We'll see later how to examine a specific country's data at the most detailed product level, the national tariff line level, as well as the more recent quarterly and monthly statistics to better understand the latest state of the market. Finally, we look at the structure section. Here we can see that the top 10 markets account for approximately 68% of world imports, and the three leading importers, USA, Germany and France, account for about 40%. TradeMap has an indicator that helps us understand whether demand or supply for a product is concentrated. This is called the Herfindahl index. We will look at this in another video. To calculate the concentration in world demand for a product, we need to square the shares each importing country has in world imports and sum these squares. If we were to perform this calculation, the resulting index value of about 0.08 would show us that world demand for this product is not concentrated. Any value less than 0.1 indicates a low level of concentration. We can also see this demand-sided concentration index value by switching to the export view, which shows us the concentration of world import demand.